This question is asking indicate the number of instructions, bytes and cycles required for the following instructions. First is STAA, STAB, and then STAA, STAB, PSHA, BRA, and then jump, and then CLI. Okay, so let's go ahead and look at each of them. Let's do the A part. In the A part of the question, the first one here we have. So here, if you look at the first four of them, it's like addressing. There are three types of addressing used here. One is exterior addressing, that is this. You see with 4 hexadecimal numbers. And then we have direct addressing, that is with 2 hexadecimal numbers. And then we have indexed addressing, that is point to the register. It has to be stored. That is this one, the third one and the first one. Okay, so based on the addressing method and where it addressed and all stuff, it's going to be, the bytes are going to be a little bit different. So let's look at the first one. First one is STAA, and this one is in indexed addressing, and here what we need to have is 3 bytes to make this happen. One of the reason is it's pointed to index y. Index y require 1 extra byte. If it's index x, it's 1 less byte, so it's going to be 2 bytes for that. But here this is 3 bytes because of the index y. And then it's going to require 5 cycle. If it's x, it's going to be 4 cycle, but y always require extra byte and extra cycle, so this is going to be 5 cycle right here. And the second part is here we have exterior addressing. It has 4 hexadecimal numbers. So we know that bytes are like 8 bits. So we need 2 bytes to represent this address. And also for the opcode we need 1 of them. So operand takes 2, opcode takes 1. Totally we need 3 bytes to represent this. 3 bytes, and then the cycle is going to be 4 cycles. Okay, and the third one we have again indexed addressing, but this time it's pointed to x, so it's going to be 1 less byte than the first one. First one and this one look similar, but this one pointed to y, here this pointed to x. So the difference is 1 less byte and 1 less cycle. So this is going to be 2 bytes and 4 cycle. Okay, let's look at the fourth one. Fourth one we have direct addressing. Direct addressing only need 1 byte because it's only 2 hexadecimal values, so each 4 bits, so 8 bits, that's 1 byte. And then for the opcode we need 1 byte, so totally it's going to take 2 bytes. And then it requires 3 cycles. And then PSHA, that is just 1 byte and 3 cycles. And then the sixth one we have BRA, that branch to new address, that gonna require 2 bytes, 1 for the opcode and 1 for mentioning where it's gonna branch to the offset value. So this is 2 bytes, and then that triggers 3 cycles. And then we have jump. Jump requires 3 bytes and 3 cycles. And the last one we have is clear interrupt flag. That one only require 1 byte and 2 cycles. Okay, that is it for the A part. And in the B part is asking which is the preferred method when interacting with a significant number of multi-controller register. When you have like multiple multi-controller registers, it's better to use the indexed method, because you can see the indexed method, you can point to whichever the index register you are using. Like for example here we have indexed addressing method used in 1 and 3. You can see the right away you can, if you want to store in X, you can do it like this. If you want to store in Y, you can do it like this. So when you have like a multiple number of microcontroller register, it's better to use index addressing method. So the answer for the B part is indexed addressing. Okay, and then C part is asking which instruction is necessary to perform first before we can use this, assuming the default microcontroller configuration. Here we have to set X is equal to 1000 before we make any of this based on the given code. Okay, and that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.